Okay, so today we're going to learn about angles inside and outside of a circle. So if you'll just look up here for a second, in figure 1, you can see that angle 1 is outside of the circle. And angle 1 is made up of two secant lines. Like this is one secant, and then we have another secant that's making angle 1. In figure 2, angle 2 is also outside the circle, but it's only made by one secant line and one tangent line. So the one on the left is the tangent, the one on the right is the secant. And then in figure 3, it's made by two tangent lines, okay? So angles outside the circle can be made by secants or tangents or both. So when we have an angle outside of a circle, that means that it actually intercepts two different arcs. So this is where I'm going to take my highlighter and I'm going to intercept both arcs that it intercepts. Highlight both arcs that it intercepts. So the first one is that it intercepts arc AB, so you can highlight that on your paper too. And the second one I'm going to highlight is arc DC. I know that these arcs are being intercepted because they're in between my angle arms, like the rays of my angle. Okay, so you go ahead and highlight on figures 2 and 3, and then we'll check it in a second. Okay, this is what figure 2 should have looked like. Everything's highlighted except for the F to G arc. And then on figure 3, you have one here and one here. Essentially everything's highlighted on figure 3. That's because it's made of two tangents. And we are going to measure these guys, and we're going to measure them using the rule that we did last time where each space is 15 degrees, just so you don't have to use a protractor to actually measure. So like on the first one, that would be 15, 30 degrees, so AB is 30. And on the second one, we've got 15, 30, 45, 60, 15, 30, 45, 60. Okay, so 120 degrees for arc DC. All right, so let's see. And for this one, the rule is actually kind of tricky for outside angles. So I'm going to go ahead and give it to you, and I'll let you try it on your own to figure out for the next one since they're so similar. So the rule for outside angles is we take the bigger arc. So in this case, the DC arc is bigger. So bigger arc. And we subtract off the little arc. So minus 30. And then we divide by 2. And so what that is going to be is equal to the measure of angle 1. So you can go ahead and do that in your calculator real quick. So 120 minus 30 divided by 2. So angle 1 equals 45. Okay, so I'm going to kind of break the rules of your notes and skip the chart because I told you the rule already. So let's skip to the conjecture so we can write down an actual formula. So our conjecture again is that the angle outside the circle equals, I'm going to say big arc minus small arc divided by 2. So with that in mind, let's try the example on the bottom. So I always like to start by labeling my picture. So in circle T, angle RCE is 57. So that's the angle that's outside the circle, RCE. So this guy is 57. And arc RE is 141. So that's the big arc. That's 141. And we want to solve for arc, let's see, BL. So that's the little arc. So we can set up our equation. So we know that the angle outside, so 57, equals big arc, 141, minus little arc, so I'll call it x because we don't know what it is, divided by 2. So I'm going to multiply by 2 on both sides to get 114 equals 141 minus x. So I get x equals 27. Do you guys agree?
Yes. Yeah.
Great. Okay. So flip on over to the next page. Okay, so on this page, now we're looking at angles inside the circle. So I know last time we talked about angles inside the circle because we talked about like central angles, but these angles that we're talking about today are angles inside that are not central angles. So notice here how like angle 4, the vertex of angle 4 is R, but R is not the center of the circle. Okay, so these angles are going to have different rules. And these angles are made by what kind of lines? Chords. Very good. Chords. Yes. Great. Okay, so actually on these, we also still have 2 intercepted arcs. So I'm going to highlight those 2. So for angle 4, the first arc it intercepts is KL. And to find the other one, we're actually going to look at the angle that's a vertical angle to angle 4 to say that the other arc that angle 4 is intercepting is actually MN. So we can do the same thing on the second circle. If we're looking at angle 5 is intersecting SV. And the other one it's intersecting is WT. Okay, so let's see. Let's count one of those. We can do that together. So if we measure angle or the arc KL, that would be 15, 30, so 60 degrees for KL. And then MN would be 15, 30, 45, 60, 75, 90. So 90 degrees for MN. Okay, so the rule for angles inside is going to be very similar to our rule for angles outside, but it's just going to have one teeny little change in it. Okay, so I want you to talk with your group, and Ms. Cody's class, talk with your group too, about the rule for this one. Okay, so talk to your group for a second about, can you figure out the rule to find angle 4? So angle 4 is going to be 75 degrees. So if your rule gets 75 degrees, then you're good to go. Okay, so real quick, talk with your group.
This is 42, but the outside is 84. So when it's
That's
what happens if you don't have
How is that 60? That's 45.
Double over.
What do you think?
90 plus 60. I think it might be. 90.
Okay, so here we go. Some were very close to figuring it out. Some did figure it out. But angles inside are equal to your big arc. And here's the change. Plus your small arc divided by 2. So when we have angles inside, the key is to add instead of subtract. So big common mistake that I see is that you guys forget which one is which. Just remember, angles inside add, angles outside subtract. Okay, that's the one thing you got to keep straight. Make sure you're doing the right one for the right problem. Okay, so let's look at an example. So example number 10. So in this circle, DN is 144. So I'm going to label that arc. And angle NCA is 68 degrees. And we want to find EA. Okay, so you don't have to write anything down yet, but at least tell your group what you would start with. Like, how would you start writing an equation for this?
Oh, 60. 180 minus 68 is line. Yes, math.
Okay, so around the room, I'm kind of hearing that you guys were finding other angles. Like you found this one first, right? Yeah. No? What else did you find? Oh, you can find this one. Yeah, essentially, you just need to either find ECA or DCN. Yeah. Which is 112. They're both 112 because 112 plus 68 is 180 because they're a linear pair. So now we can say angle inside, so 112 equals 144 plus x divided by 2. So you'd get 224 equals 144x. So x equals 80.
It's not 144 times x, that's 144 plus x.
Oh, goodness. Thank you. Appreciate it. Plus x. Oh, but x is still 80, right? Yes. Okay. Good. Thank you. Okay, can you show me on a scale of 1 to 5 how you're doing with our new knowledge today so far? Okay, we're going to go do some problems together. So next page. Okay, so let's see. We're going to do at least three of these together, and then I'll teach you a bring break game, and then I'll let you practice them on your own. Okay, so hang on with me for 3 or so problems, and then we'll take a break. Okay, which one would you rather do? Number 1 or 2? 1. Okay. Okay, sure, we can do 1 and 2. Okay, so number 1, is this an inside angle or an outside angle problem? Outside. So we're going to subtract. So our angle outside, 30, equals our big arc, 110, minus our little arc, which is x, all divided by 2. So multiply by 2 on both sides so we can start solving for x. So 60 equals 110 minus x. So x is 50. All right, for number 2, this is also an outside problem, so we can start setting that up. So our outside angle is 50, so 50 equals big arc. Ooh, we don't have a measurement for the big arc. What should we do? We're going to need some kind of expression that represents the big arc. 360 minus x, that would work, right? Because the entire circle is 360, and we've already spent x degrees on the little arc. So for the big arc, we'll do 360 minus x. So that's the big arc. So minus the little arc, so minus another x for the little arc, all over 2. Okay, so I'll get 100 equals 360 minus 2x. Or 2x equals 260. So x is 130. All right, and for the third one we do together, I want to do number 5 with everybody. So let's do number 5. Okay, so number 5 has 2 variables in it. Now sometimes when we have 2 variables in our picture, we might have to solve a system. It's possible. Sometimes you don't, sometimes you do. This is going to be one of those situations when we do have to do one. So our strategy is going to be to write 2 equations, simplify them as much as we can, and then solve a system with them. Okay, so for the first equation, I'm going to be looking at the angle where y is. So I'm going to highlight the 2 arcs that y is intercepting. So y is intercepting the arc on the left and the arc on the right. And y is an inside angle. So inside angles we add. So y equals 3x plus 13 plus 2x plus 12 all divided by 2. So we can simplify and get 2y equals, 25 plus 5x. So again, if you hadn't figured out we're going to solve a system already, if you see 2 variables in one equation, you should go, this might be a system. It's possible. Okay, I'm going to circle this one so I know what to come back to, and let's write our second equation. So now I'm going to be looking at like the topmost angle on the inside, and I'll highlight the arcs that belong to that angle. So now I'm going to be adding together my 2x and my 5x plus 11. So 2x plus 5x plus 11 divided by 2 equals so now we have to write an expression for what it equals. So I'm looking at the angles. These 2 angles right here make a linear pair. And we've already spent y degrees of the linear pair, so this other piece is just 180 minus y. So the equation that we just wrote is equal to 180 minus y. So when I simplify, I'm going to multiply by 2 on both sides and get 360 minus 2y equals 7x plus 11. So let's see, that's going to be 349 equals 7x plus 2y. And I'll circle that one. That's going to be my second equation. Okay, so now it's time to solve the system. So I'm going to write these equations on top of each other, but I'm going to move my variables around so that all the x's are on top of each other, all the y's are on top of each other, and all the constants are on their own side of the equation. So I'll do 349 equals 7x plus 2y. And underneath that, I'm going to do 25 equals, let's see, negative 5x plus 2y. Okay, so now I can subtract, oops, where'd it go? There it is. I can subtract these two equations off from one another. So 349 minus 25 is 324. 7x minus negative 5x is 12x. And then 2y minus 2y is 0, so those cancel. So x is 27. So once you get x, we can just plug into any of our equations and solve back for y. So I'm going to do 7 times 27. So 7 times 27. So I get y is 80. Do you agree? Anybody? Yes. Okay, great. Okay. And there you have it. All right, so time for a break.